Besides being a graduate of the Gatton Academy, Shelby is a geochemist who originally hails from Irvine, Kentucky. She received her bachelor's degree in geology and chemistry from WKU before obtaining her doctorate in chemistry or geochemistry from the University of Arizona. Afterwards, Shelby completed a postdoctoral researcher position at the University of Massachusetts Lowell and then moved to Indiana University, where she currently works. Through her research, Shelby is able to observe how large-scale geologic processes, both from the past and currently, alter the geochemistry of our environment, ultimately impacting plant and animal life, our resources, and us. Please welcome Shelby.
Hi, everybody. Thank you for having me. As Brett mentioned, I'm an alum of the Academy and of Western, so it's really nice to be back in Bowling Green. I lived here for a few years ago, and so it's really nice to be back here. So I am a geochemist by training, and so I want to talk a little bit today about what geochemistry is and how we can use that to our benefit. But first, I would like to take a few moments for you all to think about what comes to mind when you think of a geologist or of geology. So you can feel free to yell out words or phrases that may come to your mind when you think of what a geologist may do. Rocks, yes, I knew that would be one. Earth, yes, okay. So yes, rocks, the study of the earth, those are oftentimes things that I hear when I tell people I'm a geologist. So I've found that from my experience, when I communicate with people and I first tell them what I do, that these are some of the things that come to mind. I think people have this idea of geologists being outside, being in the field, 24/7, rain, sleet, or snow, always carrying rocks around, looking at rocks, bringing them back to their house. And while portions of this are true, I definitely have rocks around my house and in my car, geology actually is much more diverse than this. And so I want to take a little bit of time now to kind of explore some of the different avenues that geology can open up. So beyond just people who spend a lot of time in the field, geology is really exciting to me because it allows us to integrate a lot of other STEM fields into understanding things that you interact with every single day that you probably take for granted. So even being inside of this building, you are experiencing geology. A lot of the building material is dependent on geology. A lot of the stone that buildings around campus are made from are because of geologic phenomena. And so geology is really a fun way to kind of reevaluate things that you interact with every single day. Now, beyond people who do a lot of field work, there are wide varieties of job opportunities in the field of geosciences. So you have people like climate scientists who work predominantly at a computer, and they model what our climate may look like in the future depending on different scenarios. You have people like geophysicists who use physics and will go out in the field and place monitors, but come back into an office space to analyze the data that those monitors send them to try to better understand natural disasters such as earthquakes. Another component of geosciences that a lot of times people don't think about at all are things like scientific illustrators. There's actually a lot of art involved in a lot of STEM fields, and particularly geology. So how many of you all have seen a picture of what our Earth looked like whenever dinosaurs roamed? So that's all because of a scientific illustrator. So geologists may be able to gather the data to come up with what we think the Earth looked like at that time period, but it's difficult for us to put that into something visual, and so oftentimes we'll have scientific illustrators who will help us with that. So geology as a whole is a very diverse field and really exciting because of that. You can incorporate things like biology, things like physics, things like chemistry, and things like art in a lot of ways that you may not think of. So now that I've asked you to take some time to think of what a geologist may do and words associated with that, I want you to look at these three words and try to come up with what these all reference. So it should be pretty obvious, right? What clean, a hairnet, and Crocs all have in common. Do any of you all have any ideas? Doctor, potentially. Lunch lady, yeah, maybe a lunch lady would rock some of these. So, you might be surprised to find out that all of these things describe me and what I do as a trace metal geochemist. So what does trace metal mean? That means that I look at metals in rocks and rock materials that are at very, very low concentrations. So that's the reason that I have to be incredibly clean, and I have to wear things like hairnets and Crocs, because the metals that I'm interested in are in such low quantities that any sort of contamination can really impact my data. So I can't wear shoes that have been worn outside, because there may be particles or dust on the bottoms of my shoes that could then get into the lab space and contaminate my samples. I have to wear a hairnet because there may be things that have fallen on my hair that ultimately could fall into the work that I'm doing and impact my samples. You see that I have this white clean suit on, so this suit has never been worn anywhere outside of the lab space, and so anytime that I go into the lab space, I have to put it on over my clothes so that no particles from my clothes fall into my samples. So again, when you think of geologists, a lot of you all thought of rocks, being outdoors, probably getting dirty, but what I do every single day as a geoscientist is actually incredibly clean. So it might be something that surprises you a little bit. Now, what does it mean to be a trace metal geochemist? Well, again, it means working in this clean environment. And since I am studying metals, it also means working in a space that has no metal present at all. So if you look at this photo, you can try to squint and see if you find any metal, but all the cabinetry, all of the bench tops, everything in there is either wooden or plastic. So again, this is to limit contamination. So another component of geology that's very clean. Now, when I say trace metal, what does that actually mean? Well, it means that the metals I'm interested in are at levels that are equivalent to part per million or part per billion. So in a rock, when we break that up into individual atoms of different elements, the atoms that I'm interested in may only be present once for every million atoms in that rock. Or in some cases, they may be present only once for every billion atoms in that rock. So it's very, very small amounts. Now that might seem kind of like a foreign number to you all. So let's think about that in ways that may be more approachable. So let's take a number that maybe you're a lot more familiar with, hundreds. So if the metals I'm interested in were there in levels at part per 100, then that would mean that for this whole room of you all, if you all were different elements of a rock, and the element I was interested in was in a part per 100 level, I would need to go through this room and locate 6 or 7 individuals. Now, I don't know what you look like, I don't know where you are, but I would have to make my way through and find just 6 or 7 of you all. So you can imagine that would be a pretty difficult task. I mean, eventually I'd be able to do it, but it would take some time. But that's parts per 100. The things I'm looking at are in parts per million or parts per billion. So if we take the entire population of the state of Kentucky, and I was looking for things on the part per million level, that would mean I would have to go through every single person who lives here in Kentucky and locate 4. So that would be a really, really challenging task, right? So that's what I have to deal with a lot of times with these metal isotopes. I have to look for metals that are present in really, really low quantities. So you can imagine that's why I have to be so particular and so clean whenever I'm in the lab space. Now, in some cases, I'm not even that fortunate. And so the elements I'm interested in are actually in parts per billion. And so that means I would have to take the entire population of the globe and be tasked with locating 7 or 8 individual people. So it's really, really challenging, but that's part of why I find it so exciting. It's very satisfying when you're able to find those metals that you're interested in, and when they're located, with billions and billions of other elements that you're not interested in. And so it's a really powerful process. Now, why would people be interested in things that are so rare? Well, obviously, as a geologist, I'm interested in it because of rocks. So we can actually learn a lot about processes that worked in the past, as well as processes that are currently ongoing that have shaped our Earth. And so we can use trace metal concentrations to try to understand how mountains formed, for example, or how metal deposits ended up where they are. So why is gold in one area of the United States but not in another? So trace metals are actually really, really powerful geologically, but even outside of geology, certain metals can be really dangerous. So one of the metals I work with is called thallium, and it's incredibly toxic. So luckily for us, it's not typically found in very high concentrations, so it's not something that we have to worry about. But there are certain parts of the world that have elevated levels of this metal thallium, as well as things like lead. You probably are familiar with lead poisoning from some of the Flint water crisis that's happening. Other metals like mercury are really dangerous, and you can find those in different geologic environments, but also in animal life. And so it's important for us as geologists and for other scientists to understand where some of these metals are located to help us better predict areas that may be at risk for metal contamination. But it's also important for us to kind of pre-plan for remediation techniques for some of these metals. So how do we clean up areas that are already damaged? Now, I mentioned that some of these metals can be transferred into things like plants and animals. Thallium is one such material. So thallium can very easily pass into plant life, particularly plants that we consume, so things like broccoli, greens, cauliflower, Brussels sprouts. And again, unfortunately, we don't have to worry about that except in a few places in the world, but it is very important for us to understand how trace metals move around. And so I feel like the work that geochemists do has a lot of applications outside of just rocks. And so I hope going forward, when you think of geology, maybe you have a more expanded view of what geoscientists can do. Now to finish up here, today we're all talking about legacies that last, and I can't think of anything that's more appropriate than geology. Rocks themselves tell us a story of our Earth's history for billions and billions of years. And from that information, we're also able to make predictions about what our Earth will look like billions of years into the future. And so I want you all to think, as you move forward, and particularly today even, what are rocks that maybe you've passed every single day? What are some of the stories that they can tell you? What is some of the information that rocks have from their history that maybe you've never thought about? So even as you walk down to lunch today, look at some of the buildings on campus and imagine that they're all books and they're waiting for their stories to be told. And so I hope that you all take an appreciation of that going forward and start to recognize things in the natural world that maybe you hadn't thought about. Thank you.